So at the Center for Water Research, we're really trying to jam here. Like, we have been doing activities. I'm not going to take time to click through these photos, but I'm going to tempt you with them. And you can check them out on LinkedIn. We had the Student Water Jamboree, which mirrored the Faculty Water Jamboree that we did in January. We had so many great inputs, so much great swag, so many great photos. We did not actually go into the water that day as planned, but we had a wonderful time. And I just really want to appreciate the organizers. Some of you, if you are organizers, could you raise your hand so we can applaud you? You did a great job. We're jamming in other ways, too. We had this fantastic symposium only 2 weeks ago. I mean, is it only 2 weeks ago? I'm still recovering. Where we had we had guests from Israel, from Kenya, from Uganda, Malawi, talking about transboundary water issues globally. It was really exciting. And we are working to grow our profile at Northwestern in water. And how we do that is by bigging up the people who are doing wonderful things. And all of you, I don't know all of you, but 90% of you are doing wonderful things in water. And when we say we want you to tell us the cool things you're doing, we literally mean it, and we will highlight you and the cool things you're doing that are water related. And it could be water research, it could be a water grant, it could be a water sport, it could be a water related performance. This is a cantata that's coming up next in 2 Saturdays. So please, we want to feature you. And yeah, this is my opportunity to show you where we're growing. So at Watering Hole 1, I think we had 10 followers. So we've improved by a lot in terms of percentages. So you're here for the watering hole. I'm going to stop talking very soon. For those of you who are unfamiliar with the format, watering holes are short. So I'm ruthless when it comes to timekeeping. We're going to hear for no more than 20 minutes. We're going to have some Q&As. Then we're going to mingle and get calories, get hydration. We really are trying to figure out who's interested in watering holes, who's interested in water, and how we can meet your needs. So if you can, please register and give us ideas about speakers for the next watering hole. So I'm going to pass it over to George and Alaina, but I want to say that I go way back with both of these people. So this is Alaina and I at a gala.
Yay!
Before COVID.
Oh, wow.
Was it? It feels like it was... it was like a million years ago.
A million years ago. Yeah.
And this is not George.
I was going to say, it's not George.
This is George's kid, Toby. Goes to school with Aurora, who ended up selling us. But this was Toby at school a million years ago, too. So
family.
Yeah. So anyway, it's always nice to give a little fun fact about the speakers. I'm not going to say more than that. I'll leave it to George to take it from here. So let's appreciate George Wells.
Thank you very much, Sarah. Wonderful picture. I haven't seen that one. I'm going to have to get a copy of that from you. All right, wonderful. And I need this.
Oh, I'm sorry.
Well, no, that's okay. Let me just plug this in.
The VLPC.
What's that?
Environmental Law and Policies that I tell.
Yes.
Yeah. All
There's
right.
so many galas.
All right. Thank you all for coming. Such a pleasure to have the opportunity to give a joint talk, actually, with a distinguished visitor today. Alaina Harkness is the CEO of Current and the CEO of the, I think I can still call it the new engine, the Great Lakes ReNEW Regional Innovation Engine, or the Wastewater Innovation Engine. So our purpose today is to kind of give you an overview of the things that we're trying to do in the engine, talk about some of the initial activities at Northwestern, and then talk about some ways that we'd like to engage all of you in our activities in the engine going forward. So brief intro, just a little bit about me and my group. I think I know most of you here, but just wanted to make sure we're on the same page and you guys understand where we're coming from in my group. In my group, we work at the interface between microbial ecology, where we ask questions about diversity and interactions and dynamics of microbial communities and links to allergic function in both impacted natural aquatic environments and in engineered systems. We then work in the much more applied field of environmental biotechnology, where we seek to put these microbial communities to work to perform useful services for society. Most of our work, however, lies at the intersection between these fields, where we seek to develop new technologies new management strategies, new approaches for sustainable environmental and public health protection, coupled to this goal of resource recovery from wastewater. And I introduced this because this is the overarching goal, what we're focused on in Great Lakes ReNEW as a whole. And so I'm extremely excited about this opportunity. I think we've compiled a really amazing team of people and are looking for a lot more input and engagement from you all as well. In my group in particular, we're interested in microbial nitrogen, phosphorus, and carbon cycling, removal, and recovery. We're going to talk a little bit about some work at Northwestern and Vinayak Gurteev's group and Harkness group, and with Tayo and some other folks as well, thinking about recovery of some of these resources in a minute. But first, I just want to talk a little bit about the overarching drivers here in this concept of resource recovery. Really, what are we trying to address? We're trying to address what I would argue is a fundamentally outdated and unsustainable 20th century paradigm for water management in society, which is really focused on a design for linearity, for separation of different parts of the water sector, for uniform application in many cases of the same types of technologies, independent of locally tailored conditions, and for highly centralized processes. So just a high-level schematic of sort of our overall linear processing of water in general. In urban systems and cities, we tend to rely on pristine water sources from lakes and rivers, so groundwater and the like, so a limited number of pristine water sources. We use a suite of very common physical chemical processes for drinking water treatment. We then use that water in society and agriculture alike, and use inevitably degrades the quality of the water. We send this to a wastewater treatment plant, which is a misnomer even in its name because of the term waste. So I like to argue that these should be called used water treatment plants, not wastewater treatment plants. It's just likely used water. For the most part, we then produce high quality water, but we release it to a receiving water body. Now, this system is characterized by a number of pretty severe deficiencies. The system of management tends to be highly energy intensive, costly. Wastewater treatment alone accounts for about 3 to 4% of nationwide electricity use. It's prone to high greenhouse gas emissions, mostly microbial greenhouse gas emissions, methane and nitrous oxide. The current management scheme for water in general is inflexible to extreme weather events. It's not so resilient. It's not so adaptable to climate change. It's still suited to management of contaminants of emerging concern, which is one of the major focus areas of Great Lakes ReNEW. We'll get to that in a minute. It is characterized by high chemical use. Most of those chemicals are fossil fuel derived, so very carbon intensive, and it produces high volumes of residuals. So what I want to do now is I want to turn the floor over to Alaina. We're going to tag team this a little bit. We're going to go back and forth. I'm going to let Alaina give a overview of the broad organization and goals of current and of ReNEW, and then we'll come back to some of the efforts at Northwestern.
Thanks, George. Fantastic. Part of being a well-oiled machine engine is you just pass back and forth seamlessly. We've been working together a while. It's so great to be able to do this. Really great to see all of you. I hope we get to meet individually. I'm Alaina Harkness, the CEO of Current, and have had the really great privilege of being able to spearhead this initiative, Great Lakes ReNEW, this engine with George and so many others here at Northwestern, but also at campuses with students and professors and industry partners and utilities all across our region. So it has really been one of the great collaborative works of, I think, all of our careers. It's been so much fun to work on, and just have to really thank George and other colleagues here at Northwestern for being, in so many ways, the within Northwestern engine of bringing water innovation all together across disciplines. I think that is a lot of the inspiration for ReNEW. So Current, the nonprofit that I lead, also in some ways had a little bit of the origin story for ReNEW. It was a nonprofit designed to bring all of these different universities, industry, utility, and also startup partners together to try to help us move these paradigm-shifting breakthroughs in water innovation forward in our region. And we've been around since 2016. I came to Current in 2019, and since then, that's been our mission. Grow a circular blue economy. So you heard George talk about the paradigm shift from linear to circular. Help accelerate innovation. We're here to help breakthroughs that your creating breakthrough into the market, into adoption, like getting into the world and getting used faster. We know for lots of reasons that you know too that that's hard for water for a lot of different reasons. And then solve challenges here in our region. So being in Chicago, all of you know this, we've got this incredible water right out in front of us. We've got this river system, sort of lake out the front door, river systems out the back door. We're in an incredibly rich region, but we also have massive water challenges to try to solve. And so those were sort of the three things that Cohen's been working to do. These are the sorts of things that gave us the ability to go after the engine, like a track record in raising and investing funding from a variety of sources, so blended sources to do this innovation, engaging with water tech startups and helping them go to market, launching pilots, I will talk about some of those, and then reaching people through events and convening. So those are sort of, have been historically Current's anchor points and superpowers. This has been the work to put together the NSF Engines program started more than 2 years ago now, when the call first came out, and with an organizing effort that really was anchored in Northwestern's leadership as a research consortium partner to Current and many others. This is our North Star on our sort of problem statement for the engine, which for those who knows what the Engines program is, I don't know if we need to do more background.
I would do a 30-second recap.
30 seconds. Okay. So the National Science Foundation Regional Innovation Engines program is, number one, the very largest NSF program call in history. So NSF funding lots of different science, the biggest ever call, 10 years, up to $160 million. And they were supposed to be the regional moonshots for the entire country. So they weren't going to do a lot of them, and they were going to be kind of problem agnostic. You could propose anything. And so there were 700 concept papers that came in all around the country for a bazillion different ideas. And our team, George and others, got through many stages of down selection and were awarded this inaugural engine grant in March last year. Yeah. Yay! And it was a huge award. For those of you who are we're still celebrating. It is still kicking off. It was a huge heavy lift and a very competitive national process. But this was the winning problem statement for us. Today, this is back to that paradigm shift. We're sending conventional water and wastewater treatment we use today is flushing valuable things away and leaving harmful things behind. We can't keep that status quo. This is the problem. And I'll come to the solution in a second. We also have been responsible for making the case that this is a critical national security priority. Very important to connect our water needs locally with our water security nationally. So we know that the growth industries of our entire country are extremely water dependent. So data center is just one. You could pick ag, you could pick manufacturing, but just one single data center consuming the same amount of water as a town of a significant size. Today, we're putting those industries in places that are water scarce. Contamination today, we know PFAS is in like half of U.S. tap water. This is a problem that we continue to learn more and more about, but we know with certainty that it's causing harm to human health ecologies. And we know that this is costly in so many different ways. This is just one projection of how much GDP is supposed to be at risk by extreme water stress by 2050. That's like the same size of the entire global economy today. So this water risk continuum is just going up really sharply, and that's the economic risk that's not even taking into account, the harm to health and environments and all of that. So big problems that we have. We need to get out of this linear way of working and move to this waste to wealth paradigm that, again, is Great Lakes ReNEW sort of moonshot idea. Selective separation is at the core of both of those things. Getting better materials, discovered, designed, engineered, adopted, going to scale to recover valuable resources, things like the critical minerals we need to actually make the clean energy revolution happen faster, things like phosphorus and nitrogen that are critical to our food supply, and remove harmful contaminants like PFAS and many other things that are harmful to health. The better, more cost-effective, energy-efficient selective separation is the big moonshot. The moment for our Great Lakes, and something that Northwestern does very well, knows very well, along with many of our other partners. So ReNEW, this broad coalition we've built, really similar missions to Current, spurring the circular economy transition, inventing and commercializing and scaling up these selective separation technologies. And most importantly, for all of this to work really well on a flywheel, we need big industry here that we are attracting and retaining to our region that is demanding these kinds of technology. That's a big part of what we're trying to do as well. So The strategy you'll see that goes across the TRL spectrum. We have R&D projects that are at very early stage. We have bench scale test bed leads across our region that are helping to validate and prove out components of this work, pilot scale test bed validation, and then our full scale demonstration with industrial and utility pilots. Across the bottom, we're thinking a lot about the workforce that we need to be able to power this transition. Here in our region, our early stage region of service. So you see all the 6 Great Lakes states, that's where our partners come from, but we're in the second year of our engine and trying to show impact and results in these 3 states that are important centers of gravity for this water innovation already. Many partners, this list is like an eye chart, so don't worry about who's on it, but just know that there are multiple states. It's a bipartisan coalition, which is really important for us. It's also got multiple research universities, a national lab, workforce partners, industry partners, nonprofits, city colleges, community colleges, really everybody that will take to kind of move this paradigm shift forward. And then again, building on our track record, we now have a much bigger track record. We need to update this with all the impact from the first couple of years of wins, which include moving these technologies up the TRL spectrum, breakthrough research from our portfolio of our first 12 projects, more. Let's see, Joe wins, putting together the collaborative. We have more than 60 partners in ReNEW. It's an impressive coalition. It's like 200 people regularly getting together to do this. The R&D RFP that we just put out got more than 120, I think it was up to by the end, like close to 120 submissions from a closed network, which is incredible. These were high quality research, development, and translation proposals. So we're excited about that. Training and mapping of our Blue Jobs workforce across the region is underway, and people are being trained for jobs and STEM programs. And then our test bed infrastructure, we'll say more about that, but it's we have this idea of a connected testbed network that is really exciting. So I'm going to flip it back to George to go a little bit deeper on that R&D vertical, but hopefully you got a sense for the architecture of the engines overall in that sort of research and development, commercialization workforce angle. Back to you.
Wonderful. Thank you, Alaina. I want to give just a little bit of detail about the nascent phase R&D activities. We, of course, hope to expand this quite a bit in the coming years as well. So these are initial efforts that got off the ground right away with the center. I believe there are 12, if I remember right, 12 different research projects, including a couple of test beds and then some dedicated R&D projects. So a little bit of a complicated organizational chart here for use-inspired R&D. Just want to point you to the 7 R&D specific projects here, not the test beds, just the R&D projects. And I'll point out that 2 of these are here at Northwestern. We have a phosphorus recovery effort and a nitrogen recovery effort. So I kind of like this. We're heavy on nutrients, which is one of my passions here. I love that. So I just wanted to highlight a little bit about what we're trying to do as teams of researchers here at Northwestern. And then we can talk about the other projects as well. For the sake of time, I'm just going to zoom in on these. So let's start out with nitrogen. And then I'll move to phosphorus. I'm going to talk about drivers for recovery of both nitrogen and phosphorus. I'm going to focus here on nitrogen, but the analogy or the story is quite similar for phosphorus overall as well. I like to argue that we have, again, this highly linear management scheme for nitrogen in society at present, a once-through management scheme, what I call an extract, use, waste model for nitrogen management, also for phosphorus management as well. In the case of nitrogen, we fix enormous quantities of nitrogen, extract that nitrogen from the atmosphere, inert nitrogen gas, put it in the form of ammonia, using the highly energy-intensive and carbon-intensive synthetic nitrogen fixation process called Haber-Bosch, which accounts for 1 to 2% of global energy use. Much of that ammonia is used for fertilizer production. This underlies our global food system. It's also used for commodity chemical production. It's estimated that about 80% of that synthetically fixed nitrogen ultimately finds its way to the environment as waste nitrogen in some form. And the so-called nutrient pollution has a range of dire environmental and public health consequences, including direct toxicity to aquatic life, so ammonia is toxic to fish, eutrophication or excess algal growth resulting hypoxia in nutrient-limited systems, emissions of the potent greenhouse gas nitrous oxide, and then human health impacts, including methemoglobinemia, which is caused by nitrate or nitrite in drinking water, and cyanotoxins from harmful algal blooms. Now, in the best case scenario, point sources of waste nitrogen can be routed to our urban wastewater treatment plant infrastructure, which can do a reasonable job at mitigating or preventing that nutrient pollution, but has a number of severe deficiencies, including this high energy demand, again, that 3% of U.S. electricity use that's used for wastewater treatment, emissions of potent greenhouse gas, again, nitrous oxide, and the fact that in general, we're focused on dissipation of that nitrogen, that reactive nitrogen, back to the atmosphere as inert nitrogen gas, rather than recovery as a value-added product. So I think this overall scheme may come across as being a bit paradoxical, quite unsustainable in many ways. In essence, what we're doing is we're using quite high amounts of energy to first extract nitrogen from the atmosphere, put it into a useful form. We use that nitrogen once in society, usually. Much of that nitrogen ends up in waste streams that cause environmental and public health harm. And then we expend quite a bit of energy to take that reactive nitrogen and convert it back to inert nitrogen gas. So quite a challenge. Yeah. Oh, okay. So we'll try to speed up here a little bit, make sure there's plenty of time for discussion. Quite a challenge here in terms of managing nitrogen, reactive nitrogen in society. But in that challenge is an opportunity to rethink the way that we manage nitrogen in a circular nitrogen bioeconomy for a future without waste or pollution, basically intercepting that waste nitrogen and routing it back for use in society. And this idea sort of permeates a lot of what we're trying to do with Keith Tayo and others here at Northwestern. So I just want to tell you a bit about the work that we're doing through Great Lakes ReNEW. This has to do with the internal microbial storage polymer. Some of these storage polymers may be familiar to some of you in the audience: PHA, polyphosphates, glycogen, very common microbial storage polymers. The one we're interested in is relatively underexplored. Or unexplored. It's a nitrogen-rich microbial biopolymer that's used for nitrogen storage in various types of bacteria. So our focus is really trying to develop a radically new approach for microbial processing of nitrogen, where instead of putting that nitrogen back to the atmosphere, we seek to concentrate that nitrogen in a form that can be recovered as fertilizer, maybe a single-cell protein, maybe for amino acids or other value-added products as well. So this is a joint project again with Keith Tayo, and I see a couple of other people from the team as well here, and then also with Paige Novak at University of Minnesota. For the sake of time, I'm going to skip over.
Could you raise your hand if you're on the team so we know who to talk to during that?
Yeah.
Nice.
Okay,
Yeah.
team members.
Exactly.
Yes.
Quite a number of people. Our Sinophycin team. Excellent. Thank you, guys. I'm going to skip over this just for the sake of time so we have more time for discussion, because I do want to mention our focus also at Northwestern on phosphorus recovery. So not just nitrogen, we're also focused on phosphorus. This is a project that's led by Vinayak Dravid's group and Aaron Packman as well here at Northwestern, along with Linda Lee at Purdue. And the focus here is on testing and then scale up and optimization of a novel sorbent for phosphorus recovery, either from stormwater or wastewater, and then regeneration of this phosphorus as well. So just a bit of evidence that this sorbent actually works really well. Quite promising results here. We have a range of different analytes in water. On the x-axis, dissolved analytes, we have phosphate, fluoride, bromide, nitrate, sulfate, and chloride. Before in blue, and then green is after a treatment with the sorbent. And this is using secondary effluent from an actual water reclamation plant. You can see very strong accumulation of phosphates. Basically almost, well, can you see the bar here on screen? I don't know exactly what the concentration was. It was very low. Yeah. Versus all of the other analytes here, you see basically no removal. So highly selective for phosphorus and very effective at that goal of recovery. As well. Yes. Yeah. We have a couple people from Team Pearl here as well. Wonderful. Thank you guys for being here.
Also add that your team and Tom is also part of it.
That's right. Yeah. So Thomas Lippert is sort of bridging between these two projects. He's a research assistant professor now in working in my group, but between a number of other folks as well. That's right. Thank you, Vinayak. I do want to mention also we have a role here at Northwestern, not just in R&D, but also in translation, but also in workforce development. Nicole Pinkert at CESP, who's also the faculty director for the Office of Community Education Partnerships, is really leading some of that K through 12 STEM education work at Great Lakes ReNEW. So for the last couple of minutes, I do want to make sure we get back and talk about broader activities in ReNEW and ways to sort of engage the community in ReNEW as well. So
Sure.
I'll hand the floor back to you.
Thanks.
Alaina.
Well, and I think what we can do, because I want to make sure we have Q&A, we can build most of these slides and into the Q&A, but you can probably already get the sense the Engines program was designed to do some things that were disruptive to a more traditional academic research and commercialization model. One, to start everything with end user needs first. So this lab to market idea, really, we're trying to have those end users like MWRD, who's effluent year testing, those utilities and industry partners informing our research agenda right at the front end. So you're gathering them, we're asking them, what are your big waste to wealth questions? What are your big circular economy challenges? And how can we really use that to frame up our opportunities? So hopefully that came through, and we'll talk more about all the different ways that we're hoping to move this forward. But there are multiple partnership accelerators that we're working with right now as we seek to help and innovations like Vinayax and others get out of the lab and into the market faster, partnering with Generator on their Great Lakes Innovation Accelerator, which was a NOAA award. So we're actually like wrapping that in and aligning that with what we're doing with Great Lakes ReNEW, which is great. It's a big leverage opportunity, big ecosystem partnership. We've just launched a new sustainable water tech accelerator with MHub, which is a major manufacturing and hard tech center here in Chicago. That's their first ever cohort focused on water technologies. We're really excited about this, and it's bringing in new industrial partners. Yes, please keep your code there. And then we just launched last week a mining water tech pilot pathway program, which, as you saw, the focus on critical minerals and materials is really very important to our kind of national grand challenges and security priorities. So this is really exciting, brings in Nomadic Venture Partners, which is deep in thinking about how to make mining more circular, environmentally sensitive, and they're really excited about mining a bunch of technologies that will help us recover and reuse things like lithium, cobalt, nickel, those critical things from wastewater streams. So that's exciting. Yes, those are the focus areas. More to come on workforce. You already saw a little bit about what Nicole Pinkert's doing here, helping us think through STEM connected pathways. But really, there is a massive regional opportunity around workforce development. We consider all of you in blue jobs because you care about inventing breakthrough water technologies and doing the research that's going to help us think through how to manage these things better. But there are hundreds and thousands of people in the workforce that don't necessarily recognize themselves as being in those blue jobs. And we're trying to really have much better and clearer connected pathways, starting here in Illinois, but across our region. So much more to say. And we hope this is inspiring to everyone here. This is a big, grand challenge. 10 years of an engine program is a lovely head start if we're so lucky to get all the way through the full 10 years and get the full $160 million, which we did not get all up front. I get asked that all the time. Did they just cut you a giant check? Only in my dreams. Yeah. So we are working our way through milestones and trying to make sure we get all of this money deployed here in the region. But it is a big vision. It's going to take a lot more co-investment. We are certainly very fortunate to benefit from the existing co-investment of all the research universities that are part of our consortium, a growing roster of industry partners, direct support from utilities, industry partners, philanthropies. This is a giant big tent and a real movement we're trying to build here with this engine and this ecosystem that it's driving. So hopefully this mission inspired you. We'd like to say Great Lakes ReNEW is all about the technologies that are built in the Great Lakes but made to solve the world's water challenges. And we truly believe it's a global market opportunity that we have in front of us. So thank you all for being in it and part of it with us, and really excited to take your questions. So more you can find out here. So thanks, everybody.